Here's my LEGO Technic model of a 7th generation, let's say a 1983 Ford F-350. It's a model of a single cab, long bed, rear wheel drive model with the dual rear tires. So you can see how it looks here. The truck has an opening hood, revealing some mechanical stuff and an inline 6-piston engine, opening doors, and a folding tailgate. The front suspension is Ford's unique twin I-beam design that they used on their rear-wheel drive trucks, heavier duty, and still do today. So, get there, and the rear axle has a leaf-sprung live axle. Both front and rear have anti-roll bars as well. Here's the rear suspension. You see we've got a sort of leaf spring along there that bends like that. And then we've got an anti-roll bar hooked up the frame here. Then rotates this axle. It goes down that way and then back out onto here, like on the real truck. Then out and back to the frame. So if only one side moves, it doesn't. It's mostly just a technical detail. It really won't do anything at all. But it just mechanically links the two sides of the axle. And then up here we've got the more unique twin I-beam design. So the idea is we've got the steering hub up here attached on a solid beam that goes out to around there. And it's coil sprung. So you can see the basic idea here. So there is some camber change, but because the swing arm is quite long, well past the center of the truck, it's not as bad as it would be otherwise. Better than on a Tatra or swing arm type suspension. And I've also got an anti-roll bar up here. Goes from there up to here. It's more effective on the front. You can see it's pulling the other side along with it a little bit as I compress here. And this is suspended by two long hard shocks. It also has radius arms going along back here. A fairly complete interior with a full bench seat. We got a realistic steering wheel for the type of truck. And a detailed dashboard. And an opening glove box. So the remaining functions can be broken up into three main groups. First we have the basic power function stuff. This takes up 4 channels, which are drive, steering, pneumatic compressor and valve, so an auto valve setup for the rear differential lock, and then another remote controlled pneumatic valve for tipping the bed. Then in the second group we have the automatic motorized functions, which is just the automatic 3-speed transmission. And then we have the Control Plus function, which I'll get into more later. It uses 3 motors to try to make a realistic braking system. So for the drive, you can see up here we've got the inline 6-piston engine, so I'll demonstrate that quick. And then the truck is driven by 2 power functions large motors, one there and then one hidden under there. It then runs this gear, runs some CV joints up to here. Then you can see the old school differential right there that it runs through. So we'll just pay attention to the going through the bevel gears. Then runs an axle under there. So it runs a 12-tooth gear here, 16-tooth gear here, and an 8-tooth gear here. And then depending on where these driving rings are, it either goes through one of those 3 setups. And through more heavy-duty CV joints to here, through a planetary hub, and through a differential out to the wheels. So that's how the basic drivetrain works. But then from this differential, we have a 22 gear that runs out to this power function switch here, So it can move freely. Well, not freely. It's spring-loaded by those rubber bands there. So it always tries to go into this position. So, and then you can see we've got a wire hook up there. That's this servo, which runs these wave selectors. So we got first, second, third, second, first. The more resistance is put on the drivetrain, the more likely it will be to send power through the differential to flip the switch instead of drive the truck, shifting it into a lower gear. So I found in practice only gears 1 and 2 work, or 3 and 2 work, which is rather disappointing. The reason for this is that although I don't think there's anything wrong with the shifting mechanism, it's just the amount of torque required to flip the switch is greater than the amount of torque required to skip these 2 gears here, the bevel gears and the rear differential. So it never actually gets to shift into third. And then I guess the obvious thing to do to fix it would be to decrease the force on these rubber bands so that it would shift into third. But the problem is when I try doing that, because of all the friction in the switch, it'll never actually shift up to first again. So I kind of had to choose... it won't shift into third again. So I kind of had to choose between having second and third and first and second. I chose second and third. I am disappointed, though, that the third gear didn't work. So now we can watch the truck driving. If you closely observe the switch down here, you can tell what gear it's in. It's going to start out in third. Then I'm going to put it under some stress, and it'll shift down to second. So, running in first. Then if I put an obstacle in the way of these tires, if I can, you'll see it shifted down to second there. And the obstacle is too tough for this truck, skipping those gears in the rear differential. But if I adjust the obstacle a touch, it'll roll right over, shift back up to third, and keep going until it falls off my dresser. Well, probably not that far. So that's how the transmission works. You can also note that if I go into reverse, it'll just automatically shift into third and stay there, which is unrealistic, but it's a byproduct of how this transmission works. One sure thing, though, is that this truck is not something you'd really want to take out for a joyride or whatever. It's not fast, and it's not reliable. But it is interesting, I think, and that's generally what I build for. So for the steering, we have this L motor here, which runs an axle, runs a bevel gear, another bevel gear, and another bevel gear, which runs these universal joints, which run that worm gear, which run that 8-tooth gear, which runs this steering wheel up here, which is connected with the wheels, of course. So to actually move the wheels, there's a somewhat complicated linkage. So we have an axle coming down from there, in that 22 single bevel gear. It runs down to that small linear actuator at the back there. You can just see it in the video with that 12-tooth gear there. So originally I used a normal Lego one there, but I found that the internal clutch was always skipping when I steered. So I had seen some stuff about how the clutches worked inside. It's just kind of this plastic thing on the worm that squeezes together under pressure. So I ripped apart one of these fake Chinese ones I bought one time just because they were cheap. Didn't want to risk a Lego one. And then I just stuffed a wad of paper in the middle there. And right now the clutch is basically deactivated. So I have to be more careful, but I can work with that. Anyways, so it goes back there, and the other end of it is attached to this light bluish gray beam here. So the top end of it moves back and forth along with the actuator. The bottom end moves back and forth too, but can also move up and down with the suspension. So then here, well, first we have, I guess the obvious link to this side is just hooked up via that. And then on the other side we got another beam kind of going on this sort of angle, hooking up to the ball joint on here and hinged at the middle, so this wheel can move independently of that one. And then when it comes to steering angles, the truck has a kingpin inclination, it's got a caster angle, it's got, let's see, I think it actually must have reverse Ackermann geometry. It's not actually a good thing, but I guess it does. And then there's camber. That's not really steering, but I'll mention it here. It has some sort of camber, but it changes along with the suspension travel just because of the suspension design. So here's the truck actually steering. It really does struggle. I'm not sure what was making all those clicking noises, but it does move. So next I have my pneumatic auto valve driven by this medium motor here. Runs that 6L pump there, and also moves that worm gear, which moves the valve. See that better from down here. The valve moving. So one direction it does this, other direction it just does this. So then you can see I have my differential lock back here, hooked up to that pneumatic cylinder. So I can go that way, or I can go that way, just with the remote control. So that one works pretty well. It's maybe the most reliable function in the truck. So the truck also has a dump bed with these two large pneumatic cylinders here. It's run off the same compressor as the one in the auto valve, so to run the bed you basically just have to keep running it in the direction that you want the differential lock. So if you want it open, you just set it to open and keep pumping, and then you open this valve, which is done with this servo motor here. Oh, well, that was kind of dumb. I just got rid of the view. But I guess I'll just lift up the bed now, and then I'll show you the valve again later. So I'm going to start running the compressor and open the valve. It'll take a few seconds to get pressure built up, and then it'll move. So the first motion's happening there. Alright, so let's say that's good enough. So the servo runs an axle through the truck, down to here, where it then does a clever little linkage I found online the other day to flip the valve. There's other ways to do it too, but so if I go up, it does that, and if I go down, we drop the bed again. So that's how that works. So the brakes here get a lot more complicated. So on the front we've got discs. This is fairly simple, just with pneumatic cylinder pressing against there. In the back we have drums with a pneumatic cylinder pressing against that drum. But it's the control mechanism beforehand that's actually interesting. So in most Technic pneumatic models, you have the compressor and then a valve. You flip the valve one way to turn it on, flip it the other way to turn it off. But in a real car, it's all hydraulic of course, you've got the master cylinder hooked up to the brake pedal, so you push down on the pedal, forces fluid through the system, turns on the brakes, you let go of the pedal, spring or something pushes it back up and sucks the fluid back, turns off the brakes. So I was trying to replicate that here. So this powered up XL motor runs the linear actuator, pulls out these two cylinders, forces air into the system, turns on all the brakes. But in order for that to work, you have to have the right amount of pressure in the system to begin with, and you have to be able to cope with like micro leaks in the system. So I have this powered up L motor running this pump here. It just feeds air directly into the system. But now in order to know when this thing used to pump and for how long, you need to know how much pressure is in the system. So this powered up L motor is used just as a sensor for the pneumatic pressure. So I've got a red old cylinder here. I'm using an old cylinder because it didn't have the rubber seal on it. So there's less friction, it's more accurate. So it's spring-loaded to this position, but as the pressure builds in the system, it goes out, moves the lever, and backdrives this motor, which my app can then sense. So I'm going to move to try demonstrating it here, but because of that I'm going to have to use my phone for running the app instead of taking video. And so normally I'd use my trusty old video camera here, except it's not very trusty. This thing's my fourth take of this video just because of technical difficulties. So I'm going to be switching and trying to film with my laptop camera, which is going to be pretty awkward, but I'm going to give it a shot. But anyways, video quality is probably going to go down, so just be aware of that. Okay, so you can see I got my phone here with the program running. Let's see here, like I said, I'm using my laptop camera, not at all ideal. So, turned on the program. Now that L motor down there is pumping, trying to build up pressure in the system. If you look here, one of these dials is the pressure in the system as it's sensing. So it is going to start moving up. See, we got a 2 now. Oh no, it's a 5, never mind. Mirrored on the video, I think. And now it's hopped all the way up to 42 because the friction in the system was finally overcome. So that's above the margin needed for that to stop. So now I can use the slider on here to actually move the XL motor, which you can see at the top of the video. It's going to start applying brake pressure, and hopefully we can see some stuff move. So right now, up here, this is like, I don't know, around there. In the front, this can rotate fairly freely, so we'll see what it looks like after I'm done. So, cranking it up, moving out the cylinders. Alright, so in the front, didn't really have enough pressure to do a whole lot, but in the back this absolutely moved. You can't see that, can you? So right here, that has definitely moved out. If I put the drum back on, along with the wheels, got a bit more friction to moving. The front, if I kind of just wiggle the cylinder to get rid of some of the initial resistance, it does come on. It's definitely harder to rotate it now. Still not very strong, especially if I put the tire on, it'll seem to spin pretty freely. But anyway, I'm going to back off the pressure now. So now hopefully the springs in the system do their job and kind of take it out. Doesn't do it entirely there. Move to the back. I think these springs tended to be better, hard to say. But this brake system was obviously way too complicated for its own good, but it was an interesting mechanical and programming, just electrical challenge. So in that way I'm happy with it, but I don't think I'll use it again in the future. I've enjoyed the challenge. Best to go back to something that works. Overall, the truck just isn't really reliable. None of my stuff ever really is, but I always kind of hope it will be. But anyways, it met my goals of working in some interesting functions I hadn't done before. Mainly this system of brakes, the automatic gearbox, the front suspension, the anti-roll bars. It's also kind of fun to do a dually truck for the first time in a long time. It's a wider back and dual rear tires. You will note that my tires are different back to front. Probably if I had 6 of these tires, I would have done 2 at the front and 4 at the back. But just in my experience, when I see kind of junky old rear-wheel drive dually trucks, it seems like they often have kind of all-terrain tires on the back and just street tires on the front. So I tried to mimic that here. The problem, of course, is that the rims are different sizes, which wouldn't really work. It'd be nice to have like a rim that size with a straight tire tread in that scale at the front, but LEGO doesn't make that. But anyways, I think the look is pretty good, and I think the functions are interesting. So, I'm fairly pleased with this model. Meets my standards, at least.